cybersecurity sales exec here at M.A.C Solutions. M.A.C have been offering OT focused cybersecurity now for for over 20 years, and we've been working with some brilliant partners. And today I'm lucky enough to be able to invite one of them today, and I will pass over to Lars to give himself a quick introduction.
Thanks, Jack. Appreciate that. So my name is Lars. Can I switch into share my screen right now, or?
Yeah, yeah, get into your screen.
Let's do that. So hopefully you can see it. There you go. So my name is Lars Thorn. I work at TXOne Networks as a solution architect, and I'm not going to sort of like market TXOne too much, but we are a vendor that was a spin-off of Trend Micro 7-8 years ago, and we are only focusing on cybersecurity for OT environments. So that's all like the background. And today, the topic of today is looking into a little bit of the network part. But before we get into that specific piece, I'm putting my marketing cap on, because in our portfolio, it's not only network security solutions that we have in our portfolio. We also have other different kind of tools which really works and addresses different challenges you may have in the OT environment. So things like you see on the left-hand side, it's a little USB stick, which actually is an A/B scanner, which you can use in assets which don't have the ability, don't have agents, EPP agents, etc., running on it. We also have a OT EPP solution for all the different assets you may have, like if it's a Windows XP, if it's a modern asset, Windows 11, 2022 server, whatever it might be, could be applied in this case. And the whole idea with all the solutions here is that we don't really interfere with the processes and production that we are trying to secure here. But what we're getting into, and the focus of today, of course, is the network part, and that's the thing we'll go into much more in detail during this session. We also, just to sum this up, we also have a platform which covers the whole estate of our solutions, in the sense of both visibility, the risk management, the vulnerability management as well, being able to actually extract data and metadata out of all these different solutions we have, and then being able then to also do some response in that sense. So there's a big, I would say, portfolio of not just network security solutions for the operation technology environment in this case. So having said that, the topic of today, of course, is, as mentioned, being able to, how do we secure the network in the OT environment? So I'll go through a little bit of the challenges. You probably will recognize a lot of these. I'll go through what the solution looks like from a product and functionality point of view, and then I have some also best practices which we have deployed in different organizations globally here. So different ways to actually deploy our solutions from a networking point of view. So having said that, and as Jack mentioned, if there's any questions, etc., you can definitely put that in the chat or in the Q&A, of course, which is the Q&A is probably the preferred one. So if you look into the challenges from a more high-level point of view when it comes to security in this environment we're addressing, there is malware coming in from different vectors into this environment. Could be supply chain, it could be assets coming from vendors. We also, and I would say this is probably the biggest still vector into this environment, it's actually things or ransomware, whatever it might be, coming from IT now when the whole IT and OT convergence is happening. The espionage sabotage may not be, it's more like addressed from state actors and things like that. But that's sort of like the challenges from a security point of view that we see today. From a usability point of view, the challenge, of course, here goes back a little bit back to security as well, is that there is a lot of unpatched systems that are out of support, whatever that might be, which cannot be handled just by upgrading or installing new equipment, both from a operations point of view, but also from a cost point of view. And things that you probably are aware of in this environment, the biggest thing here from a usability point of view is to have production running 100% all the time, 24/7. And security, for some reason, and experience from a lot of organizations may not be the thing that helps in that sense. But the solutions that we have created and are developing tries to address this in exactly that way. So adding the security or increasing the security posture, but not interfering with the production. That's sort of like the key mission that we have here. So, of course, no breach, don't get affected by different attacks, being either directly attacked on OT, or if it's coming from a supply chain, if it's coming from IT. We want to stop that. We don't want just to detect it. And of course, we don't want these disruptions, as I just mentioned, in our production. And of course, make a implementation of security control almost invisible for the users of these automation tools that is in this environment. So that's sort of like a very high level challenge from a security and usability point of view. Pain points that we see, and again, I don't think this is if you've been or are in this kind of environment or you're working in this environment, you'll see things like, in general, a production environment, whatever that might be, normally don't have a segmented infrastructure as of today. So a flat network, of course, has a tendency or a risk to if you get some kind of exposure to a ransomware or whatever, there's no controls actually hindering that to go east-west and really get affecting the whole factory in this case. So that's sort of like a huge pain point from that point of view. If you want to start actually to control the traffic and the network in the OT environment, a lot of times you really don't know actually how the different machines actually communicate together. That's sort of like, one key thing here. Or then if you don't know that, how can you then sort of like control it? So that's the limitation of visibility when it comes to all the assets that I have and how they actually communicate. That's a real challenge as well, initially when you try to insert new security controls in this environment. And as mentioned, the unpatched systems, how do we mitigate to sort of like increase the posture and be able to actually prevent unpatched systems if they are vulnerable to stop exploitation of those vulnerabilities that may exist in that environment. And so like that goes into how do we handle vulnerabilities from a management point of view as well. And of course, that's a risk that we need to take into account. So that's sort of like the pain points when it comes to the current situation. When it comes to requirements for the network, what kind of functionality do we want in a solution that we actually inject into this environment? As mentioned, if we don't have the visibility of our assets, the ability to actually then get this visibility is, of course, is a requirement if we insert something. So if it's a security device, of course, this is something, even if it's not maybe security related, but it's something that helps us to understand what kind of environment we have and what devices we do have in our environment and how we can protect them. If it's a flat network, of course, we want to be able to segment that network, and we can do that in different ways. We have our little bit different approach to do this versus traditional IT vendors' way of using VLANs and IP addressing and things like that, or segments, which I'll go through in a little bit more detail. When it comes to these unpatched systems, as mentioned, if we can mitigate this with functions like virtual patching, that would be also a requirement from an OT point of view, and especially in this kind of environment. The ability to be able to patch, of course, is not as possible as it is in the IT environment. So being able to do a patch every month or bi-weekly, that's probably not a doable process. If we're able to actually, upgrade a system once every half year, once a year, that's actually the normal state, I would say. And then how can we then control things popping up like 0 days and vulnerabilities that pops up that we're not patched for? Then, of course, virtual patching is a control that is mitigating then that kind of risk that we're seeing, or that threat that we're seeing in this case. Going to the fourth pillar of the requirements when it comes to the OT environment, as mentioned, if we don't know what kind of traffic we have and how it actually behaves between different assets, then a ability to actually learn how that is done or how the communication actually works would be beneficial for me as an operator and as well as a security person, IT or OT in this environment. So being able to understand this by learning how the traffic actually flows through a device would be definitely beneficial as well from a requirement point of view. Things that we see more and more is as the environment IT and OT is now opening up, is the ask/requirement from if there is an IT and IT SOC as an example, being in-house or hosted by a third party, is the ability to actually get metadata or telemetry out of the OT environment, because so far a lot of these environments are like a black hole for the central organization when it comes to the SOC or whatever kind of group you have for monitoring your whole estate in this case. So being able, not just being able to protect this OT environment, also retrieve data, like if there's anomalies happening in this environment, to be able to actually retrieve this and then, of course, send this over to the SOC, which could be an OT SOC, but a lot of times what we see is that as of today, I would say most of the organizations do have an IT SOC, but if they can get this information, they get a little bit more visibility anyway of that environment, which so far has been a black hole for that organization. If we can help with that as well, that would be beneficial in injecting this kind of solution into that environment. So these are sort of like the requirements, the challenges that we do see. What we have done then from a solution point of view, how can we sort of like help in this case with specifically now talking about the network solution that we have, is we've created sort of like a 3-step process of adopting this security solution with the goal of adding and of course increasing the security posture, but not interfering with the production that we're trying to protect in this case. So we call it adoption, operation, and prevention. And I'll go through this in a little bit more detail of the way it works. So in a nutshell, as it says here on the slide, it should be easy to deploy. It should be not interfering at all with the existing environment. And going into operations, how can we then sort of like get into the state of actually understanding what we should do in the sense of both understanding what kind of environment we're protecting, because a lot of times, and this is by experience, that is not the case, that we really know what kind of infrastructure and assets we are actually having in this environment we're protecting. So getting into that learning curve and understanding of what we actually have is sort of like the next step, with the goal of going into the third step, which then would be to actually start to work with the configuration and enable all the controls that we do have in hand to sort of like increase the security posture in this environment. So that's sort of like the 3-step process that we have. And for that, going into the first part, if you want to install a device in this kind of environment, it doesn't really matter which vertical it is, but different verticals have different requirements. So if it's manufacturing, if it's oil and gas, if it's railway, whatever it might be, there might be different requirements. And of course, depending on the environmental requirements, it might be high temperature, harsh environments. It could be shocking and vibration and things like that. We need to fulfill that as well, not just having like an IT device that sort of like meets normal things like in a data center or whatever the environment could be. So being able to have a device that actually meets all the different requirements, independent on verticals, is sort of like a key thing here from a pure physical point of view. And so having the functionality that we can bring, which I'll describe in a few seconds, in both a ruggedized and a more commercial way is sort of like a key thing. And then, of course, depending on the infrastructure you have from a cabling point of view, if it's copper, if it's fiber, it should still sort of like be a device that actually meets exactly that requirement. And that's what you see in our devices, the ability to meet all these different requirements from different verticals. So if it's the different verticals, as I mentioned, there might be others, of course, as well, but these are the one I just put on the slide. There is a device that probably could meet the requirement from a pure physical point of view. So that's sort of like, key thing here. We do have, from a pure appliance point of view, two different families, one being an IPS and one being a firewall. We call it Edge IPS and Edge Fire. The IPS is, if you're familiar with the term and the functionality, as a functionality, it probably is available it is available in all different next-gen firewalls, though what you'll see in those firewalls is that the ability when you enable the IPS from a performance point of view, as an example, will be limited. Whereas if it's a specific device that's built from ground up just to be a pure IPS with the functionality that I'll go through in a few seconds as well, you'll see that it actually will meet the requirements, and specifically in this space, from a performance, from a latency point of view, and in comparison with a normal IT vendor product that sometimes is trying to be pushed down in this environment, but a lot of times you'll see that it will maybe not fully fail, but it has capabilities that doesn't have the capabilities that may be required in this environment. And from a firewall point of view, it's all like the same thing here. So being ruggedized is sort of like a key thing if you want to install this in a harsh environment. So this is sort of like the family that we have, and I'll just have a slide with all the different variants, and it really doesn't matter if it's fiber, if it's copper. You probably could find a device physically now that could meet your requirement from a cabling point of view, because that's all like the key, and I'll show you in a more best practice way the different ways you can actually install these devices. The IPS devices, as they actually looks like a switch, but they're not. It's actually, if you look at the standard series of the Edge IPS, the bigger boxes are actually just the smaller version of the Edge IPS. So take Edge IPS 103 as an example. That is a very small, compact IPS that's supposed to be installed like in a PLC cabinet, as an example. And the way you use it is that you actually take the PLC and connect it into this Edge IPS. You take the other port, which is on that device, and connect it to the switch. So this device and the segments, which is sort of like a multiply of the small ones in the bigger appliances, is a inline device where we can actually inject the security controls that I'll discuss in a few seconds here as well. So this is sort of like the portfolio of different devices we have. And again, if it's copper you need, if it's fiber, if it's 1 gig, if it's 10 gig, there is an appliance that actually physically now will meet your requirement. There is also, of course, didn't say that, but from a management point of view, these devices, they can be fully managed device by device. Of course, if you have a large estate, you probably don't want to go from device to device to do the management, both from a policy point of view or a retrieve the events, in this case, of course, as well. So there is also a solution that centralizes the management, which is called TXOne, and it can be installed either on-prem, and that's actually as I mentioned initially, with all the solutions we have, we always build our solutions to be on-prem first. We don't have a SaaS service, so even if it says cloud on this slide, we do have customers that wants to run this appliance because it's a virtual appliance in the cloud. So there's ability to deploy the central management solution either on-prem and it could be fully air-gapped with full functionality, or it can also be deployed in the cloud if that is a requirement. So either way of deploying the central management is doable either on-prem or cloud. If you're using the central management platform, of course, you can use it to some extent to handle events, respond to events and things like that. But if you're a larger enterprise, larger corporation, you probably want to export this information to either a SIEM source system, to different, maybe if you have a detection vendor or other entities which want to retrieve these events or this information that we actually have in the system. If it's asset information, if it's events happening, abnormal events, we can of course also export that via syslog or through APIs to third-party vendors, of course, as well. So it's sort of like the middleware if you have more of a bigger architecture when it comes to managing all your security environments in your organization. So that would be so the TXOne would be the middleware for doing that in the sense of integrating with third-party systems in this case. So now we've done the installation, we've deployed physically the devices here in the organization. And as mentioned, every segment, as we call it, so one port in, one port out, do have the ability and have a relay. So there's a relay that actually kicks in. Let's assume, because this is a key thing, if you install something in this environment, you don't want to break communication if the box dies. You don't want to break production if the box dies for different reasons. So we have this ability in all the different platforms, either being, just a one segment platform, or if it's 24 segments, which then can control more assets in this case. The ability to do this then, of course, allows you to always be up and running. And the ability is not just if the box breaks in the sense of don't getting power. Let's assume that it's a power failure. We do have dual power, of course, so that shouldn't be an issue, but for some reason, if that happens, the relay kicks in. If the software on the device, for some reason, is malfunctioning, there is a specific daemon that actually checks if the software is running. So it's totally separate from the operating system. If it doesn't get a reply over 3 seconds, it will, by automation, kick the relay in. So it will disconnect the security controls, but it will still keep the operation running. Again, due to that ongoing production is more important than having security control. Again, availability is more important than confidentiality. Having said that, we now install the devices physically. It's being turned on. The next step would then be to, okay, how does the traffic look like? What kind of assets do we have? And that would be sort of like the next step in this 3-step model, which we call operation. And a thing which we can help with, if you have a large deployment, we do have different tools to actually deploy configuration to the devices in a very quick and easy way. So you can actually save a lot of time to install, let's say, 50 devices, 100 devices in sort of like one shot. So, keeping hopefully the management happy when it comes to the time it actually takes to deploy the configuration that you've created. Another thing is mentioned, there is a auto-learning functionality in the device, and it's running. It doesn't have any dependencies with external systems. So this auto-learning function is running on the device. So it doesn't have to have the central management console running to actually do this. So everything is done locally on every device, learning exactly what kind of assets is running through the box, what kind of communication on a very high granular level, because again, we're in an environment which is not IT, and the applications running here is totally different from the IT world. So being able to understand the different applications running over, these specific OT protocols like Modbus, like S7Com or whatever it might be, is a key functionality that you need to have here to really understand what kind of assets you have and how the traffic actually looks like. And that's something we have, and that's something actually that as well helps you to create these rules that then allows you to start segmenting and prevent traffic that shouldn't be there from flowing through the device in this case. So that's all where you want to get to. And if you've done any segmentation project, you know that it takes time, and you need to break, the whole, or not the whole, but you need to break a lot of things and backhaul VLANs to the central firewall and put the controls in the firewall. It's in a short while it becomes really complex. Whereas here we don't have to backhaul anything, because wherever we put a device in, that's where you can start to controlling the traffic. You don't have to backhaul anything. If you have a flat network, we can start micro-segmenting right away. If you've done some segmentation, you can still keep it, but we can increase the security posture in the sense of adding the more granular control of applications run through the box in this case. So that's a key thing as well to keep in mind when it comes to the operation and learning what kind of traffic that's actually flowing through the devices here. When we've done this, now we know a little bit of what's actually running, what kind of assets we have. Then we get into the prevention or protection part, where is the key thing, or of course the key value. Not saying that the value of having visibility is less, but of course we want to get into the ability to actually stop and prevent things. And in that sense, in these devices, there are different security controls that you can enable. Everything from just pure detection and response, and all the way to the virtual patching, the ability to actually even do virus checking or malware checking on PE files over different protocols, to the segmentation part as well. Not in the sense that has been done in the IT part, when it comes to VLAN and backhauling the traffic to a firewall or a central firewall. We do it in a different way, but we give you the ability to segment in the sense that we don't allow traffic going from the asset to more than the stakeholders that the asset should talk to. Could be the HMI, could be other PLCs as an example, just from that point. So these controls are things you can then, after you've learned what you have from a protocol point of view, what assets you have, you get a list which you can just actually enable from an access list point of view. Then you can also then add all these different controls, like virtual patching allows you to mitigate tries or exploitation of the vulnerabilities that hasn't been patched. So it's really up to you what controls you want to enable. But as soon as you have that list of assets and traffic, how it flows, you can actually enable these security controls very easily in this device. So about micro-segmentation and visualize this a little bit. If we, and this is just an example, let's assume we add these edge IPS devices in your infrastructure close to the production, close to the level one ish kind of environment. And this should reflect a flat network. But if we just add these purely in this infrastructure, we're now able to actually start to segmenting that network. Segmentation in this case would mean that we will just allow. It's not segmentation in the sense which a lot of, including myself, coming from IT like 20 years ago or even 30 years ago, is actually done. This is the segmentation, and this is the segmentation done more on the traffic level, not segmenting through VLANs and IP subnets. The thing though with segmentation is that segmentation by itself just allows you to control traffic in a specific environment. And that's okay, but the big question is, what kind of control would you actually then add between the different segments? And that's where I think a lot of organizations stop or haven't even gone that far in the sense of what controls there is actually between the segments. And a lot of times the control is, I'm just allowing a specific device to discuss with this device on an IP address point, from an IP address point. Whereas where we think it really, makes sense to start looking into differentiation in controls is be able to look at the application as well, between different devices. And that's really different in this environment versus IT. So again, going back to the ability to understand these applications running on these OT protocols is a key thing. So being able to actually, between different zones, just really understand what kind of communication is being done in this zone or between zones over what channel or conduits, as it's called in this environment. For that, you need to have the ability to understand all these OT protocols and really understand what kind of devices you have. So that's a key thing. If you can then learn this, you can whitelist this, you're getting a much better posture in the sense of what's allowed through this device that we're injecting into this environment. And hence we increase the security posture really, high from that point. Having said that, even if we have that ability to really minimize the amount of traffic and what we actually allow between different assets, if there is a vulnerability which can be exploited, it is actually, a valid traffic from a pure access list point of view. Then, virtual patching comes into play. Because virtual patching and patching or IPS signatures is the way to actually mitigate from a pure access list point of view. If this traffic is allowed, then of course, there won't be, even if that traffic now can actually exploit vulnerability that may be in an asset, that access list won't be able to stop that kind of attack. But virtual patching from a deep packet inspection point of view can. So adding the virtual patching on top of the granular inspection is even increasing your security posture. So that would be the next step from that sense. So you're really now getting into a real high level of mitigation possibilities, and hopefully your attacker won't have the ability to actually go in and take over that if it's an HMI or if it's a PLC or whatever in this case. So what we call this is zero trust segmentation in OT, being able to, understanding the traffic on a very granular level, inject this device without interrupting your existing infrastructure, and then adding the ability, after we've learned the traffic flow between the different assets in this case, adding that access list on a very granular level from a protocol point of view, and on top of that, we add this virtual patch or IPS functionality, of course, which is what it is. And we do focus very much on the vulnerabilities that is published or seen in the ISS environment. Of course, we need to take care of the vulnerabilities. That's part of the IT world as well. But we do focus, our threat research focus very much on the environment that we are addressing. So very much focusing on the Siemens, on the Schneiders, on the ABB systems as well, finding loopholes that we do want to protect the organizations from being exploited by advisors here. So having said that, just a few things on best practices, and these are just examples of how devices have been injected or installed into customers' environment. And this is just examples. So it could be, the small devices. In this case, we're, just showing you the usage of the big appliances that we have. This is a way of really controlling every device by itself. So every device has a segment. So even if, one appliance here has a lot of different ports, as you see, but it's a port in, port out segment, and every segment is fully isolated from each other. So there's no backplane on the devices here. So the controls and the ability to actually try to communicate between different devices is fully isolated from a architecture point of view in the device here. So this gives you the ability to really micro-segment your environment. So in this case, it would be that every PLC, every device, etc., has their own control, has their own fully segmented ability to control traffic from just that specific device. So that would be sort of like the best case scenario if you have a huge budget. But it definitely, gives you the ability to really micro-segment your environment. Whereas in some cases, we have customers that actually deploys this more like, I wouldn't say centrally, but maybe between distribution and core, and the ability then to control traffic going between different, in this case, VLANs. So that would be another use case where you can actually implement this. And the reason why I wanted to show you this, and going back to that, we actually follow the infrastructure of the organization, is that in this case they've created aggregation links, so link aggregation, and we can just follow that in the sense that if you aggregate 2 or 4 1 gig ports to 10 gig ports, we can be part of that link aggregation, and if one fails, we just follow that. So we don't break any existing design of the infrastructure from that point. And the last one I have sort of like, just follows exactly what I said, but this is a different case. We have a, huge asset that has 2 different NICs, and then controlling which path to take is done by the infrastructure. So we don't interfere, we just follow, and there's a link state that we have between our devices. So if you have a high available design, if it's a redundant design, we can sort of like follow that as well. So these are just examples of how you can insert these devices / security controls, and it's sort of like transparent. You don't see this. There's no IP addresses, etc. It's a layer 2 device, so it doesn't really show up somewhere. So it just inserts into the physical infrastructure and allows you to control the traffic. So that's a key thing. So to summarize, what do we actually bring from a value point of view? As mentioned, it's not just the network solutions that we have, but we do have and have developed and architectured our solution in the network side, in the endpoint side, from the requirements that are in this OT environment. So it's an OT native developed product. So that's a key thing. We do understand requirements which are totally different in this environment versus in IT. And I think you got a little bit of notion that being flexible in the sense of if it's a very small environment, we have the small devices. If it's a large environment, we have larger devices. If you require different cabling like fiber or copper, there are options for that. Depending on the performance, I mean the speed you need, there are also different devices depending on the performance capability that you require in this case. A key thing, of course, as mentioned, we do build in all our devices and appliances the ability to, if the device breaks, that production, the process should still be ongoing in this case. So that's a definitely key thing. And on top of that, of course, we do add, which is of course the biggest value from a security point of view, we add all these security controls which I mentioned. So the ability to segment your infrastructure without really doing any restructuring. We have the ability to control that traffic. We have the ability to add this virtual patch functionality, so mitigate all the attempts to exploit vulnerabilities in your assets. We can sort of like protect that, and we're doing that more on the ICS side. So the signatures we have are very much focused on protecting your assets in this space versus in the IT space. But as we know, there are a lot of Windows operating systems out there in this environment as well. So we need to sort of like have a signature database that's able to mitigate both exploitation of a little bit of the applications from the IT side, but mainly we're focusing on the applications on the OT side, as mentioned before. So to summarize everything, we hope that what we can help with is having a one-stop OT native security solution, not just on the networking side, but also on the endpoint side and the infrastructure side as well. So with that, I thank you, and I hope that it's been a little bit of an introduction anyway of what we can offer and provide. And with that, I hand it over to you, Jack, if there's any questions.
Yeah, just a big thank you for you, Lars. That was an incredible presentation, and I'm more than happy to, on behalf of everyone today, that was very, very informative. I feel like we've all walked away with a load of more information on not just virtual patching network segmentation, but the wider OT protection and what we all can do to enhance our OT security. So big thank you there, and big thank you for everyone for staying to the end of today's webinar. It's